Hello friends, I am Dr. Kebas Sahu from SIT College of Engineering, Yatro, Kolhapur district. Today I am going to present on the topic rapid manufacturing process. So that are the sequence of presentation, overview of the manufacturing processes, introduction to rapid prototyping or manufacturing product prototyping, classification of rapid manufacturing processes, highlights of few RP processes. So first is the overview of manufacturing processes. So first is the traditional fabrication techniques. So the fabrication techniques can be classified in three main categories: forming operations, casting operation, and some miscellaneous operations like welding and powder metallurgy. In case of forming operation, first we have to heat the material. After heating, we have to apply tensile force, compressive force, bending force, or combination of all these forces. So in this category, first we have to discuss the forging process. In forging process, we are compress the metal by applying compressive force by using two die, top and bottom die. The forging product having strong strength and toughness. Second is the rolling process. In rolling process, we have to reduce the thickness of the bar or slab into thin sheets. In extrusion process, we have to apply the compressive force and the metal flow through the die. So we have to get the shape. We have to get the product as the shape of the die. In case of wire drawing, we have to reduce the diameter of the bar by applying tensile force. We have to pull the wire into thin wire. Second is the casting process. In casting process, first we have to heat the material. After heating, the metal is melted. So we have to pour into the molten metal into die cavity. So it can be classified in sand casting, die castings, investment casting, continuous casting. So in sand casting is the traditional process. So we have to apply the we are using green sand, and we have to prepare the mold cavity. After preparing mold cavity, we have to pour into the molten metal into the mold cavity. In case of die casting, we are using some plunger to press into the molten metal into the die cavity. In case of investment casting, we are using wax pattern as a mold cavity. In case of continuous casting, in that technique, we are using continuous cooling process. So the process is going continuous. And in case of miscellaneous operations like welding and powder metallurgy, in welding we have to join the two similar or dissimilar metal by applying heat pressure. So it is the joining of two different material. So it can be further classified uh, in different categories like arc welding, gas welding, resistance welding, electron beam welding, and many more welding process. In case of powder metallurgy process, first we have to prepare the powder. After preparing the powder, we have to compress the powder by using the press. After compression, we have to put into the our product into the furnace for sintering process and leave for 5 to 10 hours as per the requirement of our object. So the after sintering, we have to got the product. Second is the machining process. So it can be classified in two different categories: traditional machining process and non-traditional machining process. So in traditional machining process, we are using lathe, shaper, planer, milling machine, drilling machine. So by using that machine, we have to get the surface, machined surface having less surface, less accuracy. So machining is the process by we have to remove some extra material or some excess material to get the desired shape of the object. So by using traditional machining process, we have to get the surface having less surface finish and less intricate shape can be generated. But by using non-traditional machining process such as ultrasonic machining, laser beam machining, water jet machining, EBM, ECM, and some other process, we have to get this machined surface having high surface accuracy and high precision. And one more thing, we have to machine having very intricate shapes. Very hard material can be machined by using non-traditional machining process. Limitation of the traditional manufacturing process. Proper site selection. So first we have to select the proper site where the raw material is easily available, manpower is easily available, and easy for the business purpose. So the proper site selection is the major criteria for install the any plant. Longer installation time. So the installation of that plant is very long, means it needs 2 to 3 years, 2 to 5 years. Slower production speed. The production speed is slower. Higher production cost. The cost of the production is higher. Limited design complexity, means in that traditional manufacturing process, we have our manufacturing design is some limited. Material restriction. We are using material, means limited material are used. Appropriate for mass production. It is appropriate for mass production. Introduction to rapid prototyping or manufacturing. Rapid prototyping is a technique for direct conversion of three-dimensional CAD data into physical prototype. So in that technique, first we have to prepare the CAD model. After that, we have to convert that CAD model into STL file, and STL file is sent to the machine. So we have to print the our model as a physical prototype. So we have to get the our finished job. So RP allows automatic construction of physical model and has been used to significantly reduce the time for the product development cycle and to improve the final quality of the design product. Advantage of rapid prototyping: build complex geometrical shapes. We have to manufacture or build very complex shape, very intricate shapes by using that techniques. Automated the RP process is fully automated. There is no human intervention. So the error there so the chance of error is very less. Uses generic fabrication machines. So we are using some generic fabrication machines in this process. No human intervention. There is no human intervention in this technique. All process is fully automatic. Produces accurate and prototypes in short time at minimum cost. So we have to produce the product having the accurate shape, size, and high precise with minimum time and minimum cost. Disadvantage of rapid prototyping: adding initial cost. The initial cost of the machine is very high, expensive, and not economical for mass production. It is economical for only produce one or two product, not for mass production. Low surface finish and strength. The surface finish of that product is very low, and their strength is very weak. Required skilled operator. We have to require some skilled or trained operator to operate the RP machines. Limited material range. The material range is limited. Steps in RP. So in the following steps, following the RP process. First is the CAD design. Then after we have to convert the CAD model into STL file output. Then we have to go for pre-processing. Pre-processing, we are giving some slice thickness and corner thickness. Then we have to transfer the file into the machine. Then machine build the process. Then we have to go for post processing, like finishing, removing the support structure. So that so the CAD model creation. So first we have to create the CAD model. Okay. So in that technique, first we have to create the CAD model by using different different software like CAD, AutoCAD, SolidWorks. So by using that software, we are create our solid model. Then after we have to convert the solid model into STL file. STL file means standard tessellation language. So by using that software, we have to convert our model into STL file. So in STL file, we are giving the slice thickness. Means we are converting the whole object into small parts. So we are maintaining their thickness, slice thickness. So we are giving the optimum slice thickness to reduce any error. Printing the model. After slicing, we are print the model. So the printing is layer by layer deposition of the material. Means when the first layer deposit, then we have to start second layer, then third layer, and so on. Means the process is layer by layer manufacturing or deposition process. So RP machine build one layer at a time for polymers, paper, or paperboard metals. So the process is fully automatic. There is no human intervention. Post processing. In that process, we have to clean or finish our printed model. In that process involved, we have to remove some support structure and remove some extra material by detaching any support. Or then after we have to clean and after that we have to clean and surface treatment process. Product prototyping, solid modeling, and a prototype representations. So we have to use two techniques to represent our model: wireframe and solid form. So wireframe having some drawback, like it is ambiguous, and we cannot interpret the whole object. We don't know where is the corner, where is the hole. Lack of topological information, tedious modeling process, awkward user interface. So all those drawbacks, we are using solid models. So the solid modeling, it can define a solid part well, higher level representation up to the elegant and complex parts. So we have to interpret all these shapes, all the corners, all the parts by using solid modeling. Solid modeling is based on complete, valid, and ambiguous geometric representation of the physical object. So first is the complete. So point in space can be classified. Means we have to know where is the inside, where is the outside, and the outside dimension, outside surface. Valid, vertices, edges, faces connected properly. So we have to proper interpret where is the edges, where is the vertices, and all the faces is connected properly. Unambiguous, there can be only one interpretation of the object. So we have to interpret only one object. So scientists would work proposed two solid modeling techniques: boundary representation BRIP and constructive solid geometry CSG. So in BRIP process, we have to decompose our solid model into small pieces. So BRIP includes such a topological information as a solid is represented as a closed space in 3D space. Advantage: capability to construct unusual shapes that would not possible with CSG. Means it can be construct very complicated, very unusual shapes like aircraft fuel case, swing shapes. That requires less computational time to construct the image. Disadvantage: the BRIP require more storage to draw this any model, convert any model, and more prone to validity to failure than CSG. It is more prone to failure. And model display limited to planar faces and linear edges. Complex curve and surfaces only approximated. Then second is constructive solid geometry CSG. The model are constructed as a combination of simple solid primitives. So by using that CSG technique, we are using small faces like triangle, rectangle, square, cone shape, and some other shapes to model our object. Simple object are combined by using Boolean operation such as union, difference, and intersection. So the process is used the Boolean operation. So we, by applying Boolean operation, we have to union or union that saves, difference that saves, and intersection that saves. So first is the Boolean, means union operation. Suppose we have to combine the two different shapes like rectangle and cylindrical. So we are using union operations. In case of difference operation, means we have to difference the intermediate part. So we are using the difference operations. And that are the intersection operations. Advantage: high level commands, easy to construct solid model, minimum steps, concise database, uh, lead to less storage, can be converted to the corresponding variable. So the it can be construct very complex shape. It can be easy to construct, minimum steps, and that require less storage, and it is very means accurate. Disadvantage: that require only Boolean operations. So means without Boolean operation we cannot model our object. Range of shapes is modulators, means the intricate shapes are not drawn by this technique. Restricted to construct unusual shapes. So there is very restriction to construct unusual shapes, very complex shapes. Require more computational to derive the information on boundary faces and edges. So the process is based on the Boolean operation. So we have to require more computational to construct the any model like their boundary, their faces or edges. So classification of RP techniques. So RP techniques can be classified based on the raw material. If raw material is liquid, then it is known as liquid based techniques. In case of powder based techniques, the raw material is powder. In case of solid based techniques, the powder is solid wire or thin sheets. So the materials for rapid prototyping: metallic materials like plain carbon steel, tool steel, stainless steel, aluminum, copper, bronze are used as a metallic material. Polymer and polymer composite, nylon, polycarbonate, epoxies, glass filled polyamide are used as a polymer. That is ceramic, aluminum oxide, silicon dioxide, zirconium dioxide are used as ceramic materials. That are the other elastomers, tungsten, wax, stretcher, plaster are used as other material. And biocompatible material like uh, PCl, PPCl, PCl are used as a biocompatible materials. Some of the popular RP techniques. That are the popular RP techniques such as SLS, selective laser sintering, FDM, fused deposition modeling, SLA, stereolithography, and laminated object manufacturing long. So first is the stereolithography process. So in that process, we have to apply the laser light to cure the liquid polymer. So by the light source, it can be polymerized and form the solid structure. In case of selective laser sintering, we are using power. We are using powder as a raw material. So we have to apply the laser light source on the powder. So due to laser light source, it is heated and the powder is melted and joined together. So first we have to create the first layer. Then after we have to again spread the powder on the top of the first layer. So again we have to apply the laser light, and the process is going to so on up to the final object is built. Laminated object manufacturing long. So in that technique we are using a polymer paper is a raw material. So we have to apply the laser light to cut the paper layer. After cutting of first layer, we are using second layer. We are putting second layer, and after cutting of second layer, we are uses heated roller to roll on this paper cutting. So after means rolled, they are joined together, and we have to means repeated that process again and again up to the desired shape is not manufactured. That are the important references in the PPT. Thank you.